We're going to take a look at graphs of other trig functions in 1.6, including, we're starting here with the tangent function. So 1.6a is tangent and cotangent. So here are the general equations, okay, of a cotangent and tangent. Notice that all we're really doing is taking the sine and cosine out, and we're looking at a tangent graph instead of sines and cosines. But there are a few differences that happen here. The first one is that you see that there's no plus d. These graphs go north and south, okay, so up and down, and so there's really no reason for us to talk about shifting them in a vertical direction. Same thing that happens with the cotangent here. There's no plus d. The period is different as well. So the period of tangent is pi divided by b, not 2 pi divided by b. That's different than the sine and cosine graphs. Sine and cosine is 2 pi divided by b. Tangent is pi divided by b. The horizontal shift is also a little bit different. So we're going to look at this in terms of asymptotes. So we're going to look for where are the asymptotes, or where are the places that this function is undefined in terms of looking at its period. So I'm going to start with the tangent graph. So tangent, there's a start of the tangent graph. The tangent graph has a start. It's at bx minus c equal to negative pi over 2. And it also has an end. That's at bx minus c equal to positive pi over 2. The cotangent graph has a start. That's at bx minus c equal to 0. So the cotangent starts in a different place than the tangent does. And an end at bx minus c equal to the end of the period, which is pi. Okay, so then we're going to go and try to draw these graphs in. So first thing that I want to do is I want to find the period. So that's pi divided by 1, so the period is pi. I'm not going to draw that in with the tangent graph, though. I just need to know that my period should be a full pi. What I'm going to draw in is I'm going to draw in the asymptotes. Okay, so I'm going to draw in the asymptotes. The asymptotes for tangent are bx minus c, which is really, in this problem, just x equal to negative pi over 2, and x equals pi over 2. Okay, there's nothing in parentheses for me to move that horizontally. So I've got at negative pi over 2, that's over here. I've got an asymptote. And at pi over 2, that's over here. I've got an asymptote. Okay? So those are places that these graphs are undefined, that they do not exist. So I'm going to take and make sure that that distance is pi, so make sure the period is pi, and it is. If I go from negative pi over 2 to pi over 2, I go a distance of pi. So now I'm going to draw in the general shape of a tangent graph. The tangent graph is going to go in between, or halfway between, the negative pi over 2 and pi over 2. And it's going to go up to the right and down to the left. Okay? So there's the tangent graph, the general tangent graph, up to the right and down to the left. Now I could put more than one period on here. This is one period. I could put more than one period on here if I wanted to. I could go another pi away. So this would be a negative 3 pi over 2 to have another asymptote. And this graph could go like this and come back down. And I can draw as many of these in. They're oscillating, not oscillating, but they're repeating the same way as sine and cosines did. We're going to look at just drawing in one period as we go along, though. So now let's take a look at the cotangent graph. The cotangent graph, we need a period, so we are really going to be checking to make sure that the period matches up. So then this is going to be pi divided by 1, or just pi. Then we have the asymptotes, so we want to put our starting asymptote at bx minus c, which in this case is just x. There's nothing in parentheses here, so this is x is equal to 0. And we have an end here at x is equal to the end of the period, which is at pi. Okay, so I'm going to have an asymptote here at 0, and I'm going to have an asymptote out here at pi. Halfway in between, so at pi over 2, this is where this graph's going to cross the x-axis. And the cotangent, being the reciprocal of tangent, is going to go up to the left and down to the right. Again, I could put more of these, so I could go out here to 2 pi, okay, and I could draw another one, and this could repeat itself over here as well, and that would be fine. Okay, and so we have the tangent graph and the cotangent graph. Now, when we skip to continuing these notes, you can choose an asymptote or put in the vocabulary here on the second page before we actually go back and do the examples. The asymptote is a place on a graph where the line never touches, approaches but never touches. Line on a graph where the graph approaches but does not touch. That's an asymptote. Now, we're looking at vertical asymptotes, asymptotes that go up and down. There are also horizontal asymptotes as you continue learning some mathematics as we're going. Values for tangent. The tangent is equal to 0 if we look at the graph. The tangent is equal to 0 right here. Okay, so that's x equals 0. The tangent is undefined for places that this has asymptotes. Okay, and so the asymptotes are at negative pi over 2 and pi over 2. And so this is at negative pi over 2, pi over 2, etc. If we were making it general, remember we did this general, we're doing the pi over 2 plus pi k. So every period starting at pi over 2, this is going to have an asymptote there. The cotangent, so cotangent values, so we look at the cotangent graph. We want to know when that's equal to 0. Cotangent is equal to 0 here at pi over 2. And the cotangent is undefined for x's. Where are those asymptotes? They're at 0 plus every pi after that, so that's 0 plus pi k. You could also say that this is undefined at the period. Okay, you could say that. You could say that tangent is equal to x at the period too. You could say that as well. Okay. So those would be fine answers for that. Places that kind of extend our thinking about what this graph actually looks like. Well, we'll take a look at the examples, moving them around, doing some horizontal shifts and things to them as we look at the next portion of the video.